when you're finding roots, what you're doing is you're reversing um, doing exponents. So for instance, if I show you 4 to the power of 2, 4 to the power of 2 is 16. But if I can go in this direction, I need something that will actually take me backwards, because that's what math is always about. It's reversing yourself. You always need a way to reverse yourself. And the way you reverse something that you brought to the power of 2 is you do this. Now, this is called a radical. Okay, and what the radical says is, what did I multiply times itself to give me 16? And what I multiplied times itself to give me 16 was the number 4. So that gets me back to the root 4, and that's why we say roots. This was my number 4. It's the number I multiplied times itself twice to give me 16. This would be my square. So square and root, that's where this comes from. So when we do this, again, it's called a radical. That's the name of the symbol. It's not usually called a squared radical or a squared root symbol. It's called a radical. Now, you'll notice down here, in the crook, or in that little space, there can put a number in there. And that number is called an index number. Now, you'll notice that they put the number in there as a 3. What it says is this: what number do I multiply itself multiply itself 3 times to give me an 8? Well, what number multiplied by itself gives me an 8? It's 2, because 2 by 2 is 4, and by 2 is 8. How many 2's? 1, 2, 3. 3 2's. Now, this is called a cube, or a cubed root. This, if you'll notice, does not have a number, but it does. It's an imaginary 2. And this one is called squared. That's why they call this symbol the squared root of 16. And when they call it down here, they call it the cubed root of 8. So again, that number is called an index number. Now they can put any number they want. They can put 121 up there, and they can put a 10 here. It doesn't matter what it is. It's called an index number, and it still says the same thing. What number did I multiply times itself 121 times to give me a 10? It's exactly what it says. Now, the good thing is that I don't have to figure that out. I got a fancy calculator that can do this for me. So I just want to express to you what it is and the vocabulary associated with it. Now, perfect squares. Perfect squares are whole number squares. For instance, 3 to the power of 2, 9. The whole number 4 to the power of 2, 16. The whole number 5 to the power of 2, 25. These are perfect roots, or perfect squares, where, for instance, this is where you come geometry. And in geometry, 3 to the power of 2, or 3 by 3, means that my length is 3 and my width is 3. And when I multiply those two together, I get a perfect shape square. And that would be something you would do in geometry, or if you're a carpenter and you do building. That's what it looks like. So if you tell a carpenter that your room is 4 by 4, well, they're going to say, oh, okay, it's a square room then. And you're like, yes, it's a perfect square, where one side is 4 and the length is 4 and the width is 4. It's a perfect square if you multiply it together. So that's why that's called a square. Now, imperfect squares mean all the decimals, all the space between the whole number 3 and the whole number 4. All the space between the whole number 3 and 4, you still can have decimals like 3.215341112, whatever. So if you have a number that you multiply times itself, and it's between that, that's called imperfect. It's called imperfect because it's not a whole number, It's got decimals. And if it has decimals, it's not perfect. It's not a perfect shape. So when we do imperfects, what they look like is something like this. What is the square root of 5? Well, I don't know what the square root of 5 is because it's not perfect. I know what the square root of 2 is, which is 4. Square root of 4 is 2. I know that. And I know what the square root of 5 is. Square root of 25 is 5. So I know that the square root of 5 is between the square root of 4, which is a 2. Oh, I'm sorry, not the 5. Let me erase that real quick. Start over. You don't get mad at me too much. And the square root of 9, which is a 3. So this square root of 5, whatever it is, it's a decimal. And that decimal is between here. It's between the numbers 2 and 3, which make it 2 point something. It's 2 point something times itself will give you the square root of 5, or 5. I don't know what it is, but think how we have our calculator. If I go to my calculator, let's go ahead and do this. I don't know if this web calculator is going to work. Oh, it's probably not. But we'll express this in another video, maybe the next one, so you can look at it. So let's look at this symbol now. Here we go. Do you see this symbol here? Again, it's not negative. I know it seems like that. And again, we just worked through integers, so we're trying to learn, well, what does this mean? It just means the opposite of. Now, again, it doesn't make it the negative square root of 4. It doesn't say that. It says the opposite of the square root of 4. So what you would do is you'd say, well, what is the square root of 16? You would say, well, that number is a 4. And I'd say, yeah. Now, what's the opposite of positive 4? Negative 4. Again, it's going to take you time to understand those symbols. Please take your time. I know it's a little difficult to understand now, but you will get there. All right, something for the GED. Now, the GED will say you need to have in your memory all the squared roots, or the squares, from 2 squared all the way to 15 squared. And you would have to know these by memory. So again, remember, on the GED test, the first 7 questions of that test you will not have a calculator. But then again, some of those problems are not going to be something very difficult. It might be something like this, where maybe it's 2 to the power of 2 times 3 to the power of 2. Now, if you know the squares, then you say 2 times itself is 4, times 3 times itself is 9, and 4 times 9 is 36. It might be something that simple, but you won't have the calculator to help you. You will need to know that they are these. So all the way from 2 squared all the way to 15 squared. Another thing you'll need to understand is you'll need to know all the cubes, which means you'll need to know 2 to the power of 3, which is 8, right? All the way to 5 to the power of 3, which is 125. You'll have to know all of these in between. Now, there's not very many. And the reason that they ask that you know those by memory is because all of these are very common in geometry. We use these quite a bit. So they would ask that you know these by memory.